Hey everyone, and welcome to this explainer. Today we're going to strip away all the magic of the web and look at the exact building blocks that create the websites you're using every single day. If you've ever found yourself wondering how a seemingly random screen full of code magically turns into a beautiful, interactive application, well, you are absolutely in the right place.
Okay, real quick, before we get too ahead of ourselves, let's just do a tiny check-in right from our source material to test your baseline knowledge. So HTML is a blank language. Is it A, markup, B, markdown, C, hypermark, or D, mark hyper? Just lock that answer in your head and we'll reveal it in just a few moments.
All right, let's take a look at our roadmap for today. We've got 5 main stops. 1, the front-end foundation. 2, structuring with HTML. 3, styling web pages with CSS. 4, JavaScript and interactivity. And finally, 5, the modern browsing ecosystem. Let's just dive right in.
Starting with Section 1, the front-end foundation. To really wrap our heads around front-end tech, we need a solid mental model. And honestly, the classic house-building metaphor, it hits the nail on the head for illustrating our 3 core pillars. The crucial takeaway here is that every single modern web page relies on 3 distinct layers working together. It's a package deal. HTML is the framing of the house. You know, the walls, the roof, the raw structure. CSS is your interior design. The paint colors, the aesthetics, the vibe. And JavaScript, well, that's your electricity and plumbing. It's what actually makes the house functional and interactive. Moving on to Section 2, structuring with HTML. And hey, by the way, this answers our opening quiz. Option A was the winner. HTML is indeed a markup language. So HTML is all about organizing information cleanly and hierarchically. At the very top, you've got the head element. This works entirely behind the scenes, holding things like metadata and your page title. Then you have your container elements. These are pretty straightforward. They have a start tag, the actual content, and an end tag. What's cool is that HTML5 introduced some incredibly powerful new structural tags, like header and hgroup, which help developers organize a document's outline way more cleanly than in the old days. And you can really see the evolution here. We move from just basic structure to actual formatting. While your standard H1 through H6 tags create a strict size hierarchy, HTML also uses specific semantic tags to do things like boldly emphasize text, show deleted text with a strike through, or pop in a superscript. It just makes the code so much more readable, both for the developer writing it and the browser trying to render it.
All right, Section 3, styling web pages with CSS. With the frame of our house totally secure, we gotta paint the walls and arrange the furniture, right? That brings us to our rule-based language, cascading style sheets or CSS.
Let's look at exactly how this happens under the hood. The journey starts when you, the user, request a web page via a URL. The server fires back with the HTML and any linked CSS files. But step 3 is where the magic happens. The browser's rendering engine steps in, executes those CSS rules, and applies the formatting directly to the raw HTML. That process right there is what creates the visual layout you actually see on your screen.
But CSS isn't just about static colors and fonts. It actually reacts to what the user does. Think of CSS pseudoclasses, kind of like a motion sensor light in our house metaphor. The style dynamically changes, but only when a specific state is triggered. So a link might be standard blue by default, but then it completely changes color the second you hover your mouse over it or click to make it active. In modern CSS, it's ridiculously powerful. It allows for highly complex layouts without leaning on clunky external plugins. Take the CSS subgrid feature, for instance. It lets nested child elements perfectly align to the tracks of their parent grid. This level of nuanced responsive design is exactly what ensures a website looks flawless, whether you're viewing it on a massive ultra-wide monitor or just checking it on your smartphone.
Which brings us to Section 4, JavaScript and interactivity. So our house is framed, the walls are painted beautifully, the furniture's in place, it looks amazing. But we need things to actually do something when we interact with them.
This is exactly where JavaScript steps up to be the electricity for our site. JS gives you the power to dynamically manipulate HTML elements on the fly. It uses event handling to essentially listen for specific actions. You know, a button click, a page load, things like that. And honestly, most impressively, with HTML5, JavaScript lets developers create 2D drawable surfaces and control video playback natively right in the browser. Gone are the days of begging users to download some third-party plugin just to watch a video.
Now, I'll be real with you. Writing raw JavaScript for complex, heavy animations can get incredibly tedious. That's exactly why the community created libraries like jQuery.
Think of it as a massive pre-built toolbox sitting on top of JavaScript. It abstracts away the really hard, repetitive parts, which keeps your script super short, concise, and just way easier to manage.
All right, moving into Section 5, the modern browser ecosystem. We've got our HTML, our CSS, and our JavaScript all beautifully written and tied together. Now, let's see how all this code actually makes it to the end user. Because here is the dirty little secret of the web. Browsers are absolutely not identical. They use entirely different rendering engines to interpret the exact same code. Safari and iOS devices use WebKit. Mozilla Firefox relies on the Gecko engine. Internet Explorer used Trident, and older versions of Opera used Presto. Every single one of these engines reads your code just a little bit differently. Which leads us to a critical, and let's be honest, often painful question for developers. Will your meticulously coded, beautiful website look exactly the same on every single browser out there? Yeah. The unfortunate reality is, no, it won't. Cross-browser compatibility is arguably the biggest headache in front-end development. Some advanced HTML5 features or complex CSS layouts, like that awesome subgrid we looked at earlier, might be perfectly supported by Firefox's Gecko engine, but completely ignored by an older version of WebKit. This makes extensive testing across multiple browsers and devices absolutely vital. If you want consistent user experience, you have to test everywhere.
So now that you really understand the foundational triad of the web, the structure, the style, and the interactivity, it kind of leaves us wondering about the road ahead, right? With AI and automated development tools getting so incredibly powerful, how are these three core languages going to adapt to the future? Are we still going to be writing HTML by hand in 10 years? Or are these languages basically just going to become the invisible assembly code of tomorrow's web? It's definitely something to chew on as you continue your own coding journey. Thanks so much for joining me on this explainer, and keep exploring.